Hello, good morning my dear lovely students. In the last class we discussed about the allied angles, isn't it? Okay, today we are going to continue that concept, that is the allied angles. When we are writing, that is the allied angles of like minus theta, 90 plus or minus theta, 90 plus or minus theta, 180 plus or minus theta, 270 plus or minus theta, 360 plus or minus theta with respect to an angle theta, isn't it? Now, we have to keep, that is the three important points. The first one is when the angles are, that is the 180 plus or minus theta, 360 plus or minus theta and minus theta. If I use these angles in terms of allied, we have to take same ratio, isn't it? We have to take same ratio, that is sine to sine, isn't it? Cos to cos, same ratio, sine to sine, cos to cos, tan to tan, cot to cot, cosecant to cosecant, secant to secant. Second one, the angles are 90 plus or minus theta, 270 plus or minus theta, then we have to take co-ratio, isn't it? We have to take co-ratio, that is the take co-ratio, co-ratios. That means for sine, we have to take cos, sine we have to take cos, for cos we have to take sine, tan we have to take cot, for cot to take tan, for cosecant we have to take secant, for secant we have to take cosecant, isn't it? And third one, that is the sine, SIGN sine, according to the quadrant rule, according to quadrant rule, that is ASTC rule, what we call as quadrant rule, isn't it? What happens if more than 360 plus or minus theta? That is, if the given angle we have to write in the form of n into pi by 2 plus or minus theta. This is, we know, an allied angle. N is even. If n is even, we have to take same ratio. N is even, take same ratio. That means for sine, sine, cos, cos, tan, tan, cot, cot, cosecant, cosecant, secant, secant. We have to take same ratio. N is even, we have to take same ratio, and sine according to the ASTC rule. And we have to apply the sine according to the ASTC rule, my dear students. What happens if n is odd? Extended of this one, if n is odd, isn't it? Odd, then we have to take co-ratio. Extended of this one, these are the particular angles, this is extended of. That means for pi by 2 plus or minus theta we have to take co-ratio, 3 pi by 2 plus or minus theta we have to take co-ratio, 5 pi by 2 plus or minus theta we have to take co-ratio, 7 pi by 2 plus or minus theta we have to take co-ratio, Similarly, for phi, isn't it? Are you understood? Listen carefully. For example, if apply 2 is the even 2 pi, 2 together cancel, we get pi, isn't it? Are you understood, all of you? If there is a 4, then we get 2 pi. There is a 6, then we get 3 pi, 4 pi, 5 pi, 6 pi. That means take same ratio. If n is even, we have to take same ratio. That is the here. If I consider 2 pi by 2 plus or minus theta, 4 pi by 2 plus or minus theta, isn't it? 6 pi by 2 plus or minus theta, 8 pi by 2 plus or minus theta. That is, we get in the form of, my dear students, 2 pi, 3 pi, 4 pi, 6 pi, 7 pi, 8 pi, 9 pi plus or minus theta, then we can take, that is the same ratio, and sign according to the which one? ASTC rule. Are you understood, all of you? Some of the problems are there on this concept, we have to do later. Yes. Now we have to move another important concept, what we call as here domain and range of a trigonometric functions, my dear students. Domain and range of a trigonometric functions. My dear students, we know the values of trigonometric functions for respective degrees like 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, isn't it? 180 degree, 270 degree, 360 degree, and also that is the negatives. That means minus 30 degree, minus 45 degree, minus 60 degree, isn't it? That is, we know some of the standard values of trigonometric functions. For example, if I take for 3 functions, that is the 0, 30 degree, 45 degree, 60 degree, isn't it? 60 degree, next one is 90 degree, 180 degree, 270 degree, 360 degree. If I take this process also continuous here, negatives. If I take sine, cos and tan for these 3 functions, my dear students, you know sine 0 degree how much? That is the 0, isn't it? Sine 0 degree 0. Sine 30 degree we know 1 by 2, 1 by root 2, sine 45. Sine 60 root 3 by 2, sine 91. I think all of you are you know, yes, sine 90 is 1, my dear students. Yes, next one is sine 180, 0. Are you understood, all of you? Yes, my dear students, sine 180 is 0. Next sine 270 is minus 1. Next sine 360 is 0. Isn't it? For cos, from 90 we know sine 90 is 1, sorry, cos 90 is 1, 30 is root 3 by 2, 45 that is the same of sine 45. and cos 45, both are same. This one is 1 by 2, this is 0. Yes, my dear students, all of you, this is how much? 0. Are you understood, all of you? Yes, this one is minus 1. Are you understood? Which one? That is the cos 180 is minus 1. This is 0. This is 1. Are you understood, all of you? Yes. Now for tan. Now for tan. Sin by cos, we know. That is sin by cos is 0 by 1 is what? 0. This is 1 by root 3. This is how much? 1. This is how much? Root 3. This is not defined. Am I correct? How? 1 by 0 not defined. This is 0. This is also not defined. That is minus infinity means not defined. This is 0. Now with the help of this one, we are going to define domain and range. See here. How, sir? See here, this is the continuous. We can write up to infinity. Here also we can write up to minus infinity, isn't it? And also, my dear students, for sin and cos, if we complete one revolution, my dear students, this completes 360 degree, that means 2 pi radians. Consider a point P, then after completing one revolution, for next completing revolution, the radians degree changes, and also here the values of sin and cos, especially the values of sin and cos will repeats. Are you understood, all of you? Repeats. That means we get same values. That means for sin of 2n pi x, my dear students, 2n pi plus x, we can write, my dear students, sin of, my dear students, 2n pi plus x. We can write sin x. We can write sin x. Similarly, cos of 2n pi plus x, we can write cos x. That is the same. For if we complete one revolution, this one, that is the point P, then we get the repeats the values which are same. Which are what? Same. Then here for sin 2n pi plus x, we can write sin x. Cos 2n pi plus x, we can write cos x. Isn't it? Where n belongs to z. Where n belongs to z. Listen carefully. See here. And also for sin 0, 0, listen carefully. Sin 180, 0. Sin 360, 0, and also repeats for every revolutions, isn't it? Revolutions, that is the repeats. Generally, we can write for sin n pi, which is equal to what? 0. If I take n is equal to 0, that is the sin 0, 0. Yes? Are you understood? N is equal to 1, that is sin pi 0. N is equal to 2, that is sin 360, 0. That means we can write here, my dear students, listen carefully. Sin n pi is equal to 0, where n belongs to what? Z. Yes, where n belongs to what? Z. Are you understood? What about cos here? Cos 90 is 0. Yes, cos 90 is 0. Cos 270 is 0. That means cos of 2n plus 1. Are you understood? Cos of 2n plus 1 into pi by 2 is equal to 0. That is the multiples of where n belongs to z. That is important where n belongs to z. That is sin n pi is equal to 0, n belongs to z, and cos of 2n plus 1 into pi by 2 is equal to 0. That means n belongs to z. That means cos pi by 2 is 0, cos 3 pi by 2 is 0. Hard multiple of pi by 2. Hard multiple of pi by 2 of cos always ಏನಾಗಿರುತ್ತದೆ 0 ಆಗಿರುತ್ತದೆ. ಅದನ್ನು ಗಮನದಲ್ಲಿಟ್ಟುಕೊಳ್ಳಬೇಕು. Are you understood, all of you? Yes. Yes. Now we have to move on from this concept. We are going to write, that is the domain and range. See, under the conditions of these, we can write domain and range of 6 trigonometric functions. How, sir? Listen carefully, my dear students. That is the 6 trigonometric functions: domain and range. You know, my dear students, already I explained in functions. The function y is equal to f of x from a set A to set B. A is called as domain, B is called as codomain, isn't it? The images of set A, what we call as range of a function. Already I explained. ನಾನು ಹೇಳಿದ್ದೀನಿ ಹೌದಾ? That is the images of the elements of A which are present in B, what we call as range of this function. Now we are going to domain and range of this function. For these values, both positive and negatives, my dear students, we get respective values for sine, cos and tan, and also which repeats, especially for sine and cos, especially for sine and cos. That means we get the values like this. In these values, which is the maximum value for sine and which is the minimum value for sine and also cos, my dear students. We can give, that is the infinite values, no doubt, domain. These are all what we call as domain, extended, what we call as domain, isn't it? Then domain of sin x, we can write set of all r, isn't it? We can write set of all r. For set of all r, we get the range. These are the values. These values which repeat for second cycle, isn't it? For third cycle, fourth cycle, especially for sine and cos. That means in these values, the maximum value is 1 and the minimum value is minus 1, isn't it? That is the all the values which are lies between for sine and cos for any value of domain 1 and minus 1. Therefore, the range of sine function, the range of sine function is closed interval minus 1 comma 1. Yes, are you understood? All of you, are you understood? Where sine, set up all reals, domain and range is minus 1 comma 1. Because of minimum value is minus 1 and maximum value is what? 1. This is the domain of our sine. For cos, here, for cos, domain, This is also set of all R, no doubt, no doubt, set of all R. Yes? Yes? What about range? Range also for observed here. The maximum value is how much? 1. The minimum value is how much? -1. Range also same of sine and cos. That is the domain and also range. Domain same for sine and cos, range also same for sine and cos, my dear students. What about tan? Listen carefully for tan. See, these are the values. Not defined means that is up to infinity. We can write infinity symbol, isn't it? Isn't it? That means we get up to infinity, no doubt, no doubt. Here also up to minus infinity. That means we can write R, no doubt, domain. Sorry, domain up to infinity, no doubt. But listen carefully. For 90, we get not defined. For 270, we get not defined. That means for the function of tan, which is not possible to give, that is the 90, 270, so on, so on, so on. That means odd multiple of pi by 2. Are you understood? Odd multiple of pi by 2. Under the domain of odd multiple of pi by 2, tan function is not defined. For that, r minus of 2n plus 1 into pi by 2. Are you understood? R minus of 2n plus 1 into pi by 2. Are you understood, all of you? 2n plus 1 into pi by 2, because of we get not defined, not defined. Yes, and also we know the one of the formula tan x is equal to sin x by cos x. That is quotient formula. Tan x is equal to sin x by what? Cos x. For sin x by cos x, yes, all of you, are you understood? For sin x by cos x, for cos, see 0 for 90, 270, 0, that is anything divided by 0, we have infinity. For that, minus of this one. That means this is defined set of all reals except odd multiple of pi by 2. If I give that is the odd multiple of pi by 2, we get infinity. That means not defined. Are you understood, all of you? Yes, this is. What about range? We get set of all reals, my dear students. That is the R, no doubt. Over R, the interval we can write minus infinity comma infinity, open interval minus infinity comma infinity. Are you understood, all of you? Yes. What about cot? This is R, no doubt. R minus of, my dear students, cot can be written as cos by sine. Cos by sine, that means R minus of n pi. Yes. R minus of n pi, set of all n pi, set of all n pi, isn't it? For this one we get infinity. That means under this condition the cot function is not defined. Are you understood, all of you? Yes, that is the range of this function. We get that is the set of all reals. This can also be written as that is minus infinity comma infinity, my dear students. Are you understood, all of you? Yes. What about cosecant function? For cosecant function, my dear students, listen carefully. For cosecant, 1 by sine. For cosecant, we know the reciprocal formula 1 by sine. Yes, 1 by sine. That means 1 by 0. 1 by 0, that means set of all R minus n pi, minus n pi, isn't it? Minus n pi. That is the here in the last class I given a table, this one, isn't it? for cosecant, those are the values lies, listen carefully, set of all reals, but open interval minus 1 comma 1, that is the any value which is does not exist between minus 1 and 1, along with minus 1 and 1. Listen carefully. Yes, that is the r minus of minus 1 comma 1. Are you understood, all of you? Yes, that is the r minus of n pi domain, and range is r minus of minus 1 comma 1. That is we have to keep in our mind, my dear students. Are you understood, all of you? Yes. Similarly, last one is for secant r minus of 1 by cos reciprocal, that is the 2n plus 1 into pi by 2. This is what we called as domain, and range is same of this one, that is minus 1. Yes, this is the domain and range of a which one 6 trigonometric functions on the basis of this table. Are you understood, all of you? You have to keep in our mind. In this we know that is the y can be expressed as a what? Range, and x can be mentioned as a domain. We can also write that is the here x set of all reals, that is the minus infinity, isn't it? Less than x less than infinity. We can write like this. Here set of all reals except this one, set of all reals except this one, set of all reals except this one, set of all reals except this one. But y indicates, or f of x represents, that is what we call as range. Then here minus 1 less than or equal to y less than or equal to 1, that is also expressed in the form of a as a inequality form. But these are all in intervals form. Are you understood, all of you? Yes. On the basis of this and what I discussed in previous classes, on the basis of this concept, we have to move in the next class, that is the problems which are related to express one trigonometric function in terms of other trigonometric functions. Yes, I will continue in the next class, my dear students. Okay, thank you very much.